Okay, so let's start with assignment 3. Let's just share my screen. So assignment 3 is on SARSA, the SARSA algorithm and the Q-learning algorithm specifically. And we will implement basically these algorithms for and see various variations of them for a simple example, which is the cliff walking in the cliff walking world. So I'll briefly explain what this setting is before we move on to the implementation. So in this setting, we basically have the agent moves around in a grid world. Within this grid world, the agent always starts from the place which is marked by S. And for every movement between the grid, if the agent moves from one grid to the other, then it gets a reward of -1 for movement. And there is also a cliff within this world. If the agent moves to this cliff from any position, then it gets a reward of -100. So basically the agent can move within this environment, and the episode terminates if either the agent falls into the cliff or it reaches the goal. For when the agent reaches the goal, it gets no extra reward, but then the episode terminates. But it falls into the cliff, then the episode terminates and it gets a reward of -100. So basically here we want to discourage falling into the cliff and basically promote termination when the agent reaches the goal. So for this, we'll basically, to implement this setting, we'll import various things that we'll use. The cliff walking environment we'll use here, and some plotting tools as well, which we'll use for like executing this. We'll basically create the environment by calling the cliff walking environment function. We can render and visualize the environment basically. Here, it will render the current state of the environment. So here the state of the environment is, it has started here. These are the cliff locations, and the terminal state is given by T, and all the other available states are given by O. Okay, so at each state, agent can take 4 actions, either to go in each of the 4 directions. So it can move in each of the 4 directions, and those actions are given by 0, 1, 2, and 3. So 0 is up, 1 is right, you have down, and then you have left as well. Okay, so before moving on, we'll use some helper functions which will help us implement SARSA and Q-learning. So we'll define those helper functions before going there. I'll briefly explain these helper functions. So the first helper function that we'll use is make epsilon greedy policy. So this helper function takes in the action value function Q and epsilon and the number of actions that are available to the agent, and it will create basically a epsilon greedy policy using these. So an epsilon greedy policy will be created, which will give weight 1 epsilon by number of actions to all the actions which are not the best actions, and the remaining weight to the best possible action. So this is what the function does, and it will return a policy. So yeah, next, the other function that we'll use is to generate rollout stats. So I'll briefly explain why we are doing this. So as we have learned in the class, the SARSA algorithm is a on policy method. So on policy method would mean that, like, while learning, it follows a behavioral policy. and this behavioral policy which is learned is same as the target policy. So target policy is the policy which is executed after the learning happens. So for SARSA, the target policy and the behavioral policy are same. So it executes basically same behavior while learning and also while executing the learned behavior. But for Q learning, the behavioral policy is different from the target policy. The behavioral policy which we use, so that is why it is called a off policy method. So Q learning, for Q learning, the behavioral policy is different from the target policy. So this rollout stats, the function that we are defining, will help us track how the target policy for Q learning performs while we are learning. So this function basically rolls out the current learned policy for one episode and basically generates what reward we got, and also for how long the episode was, for how many time steps this particular episode was. Okay, I hope this is clear. So it will basically return the episode length and the episode reward for a particular policy. So for Q learning, we the behavioral policy is generally an epsilon greedy policy, but the rollout policy is, or the target policy is a greedy policy. So we'll roll out a greedy policy for the current action value function that we have, and then we'll generate stats for that particular episode and store these. Okay, so the assignment, the first question is the assignment is to implement the SARSA algorithm. So the base code for the algorithm is given, and the algorithm, we only have to, for this part, you are required to only code the update, which is the temporal difference update for the SARSA. So this update is the only part which is required for you to code. So the algorithm that is followed is the simple algorithm that is discussed in class. This is the SARSA on policy algorithm. The algorithm is implemented as it is, and only the update step is required for you to code, which is this step. Okay. So the function, basically, the function uses the environment and the number of steps that are that the algorithm will perform training for, the discount factor, the learning rate, and the epsilon for the policy that it will use. Okay. The function basically first initializes a default Q, which is the action value function for the environment, and this stats are used to basically store metrics while learning is happening. Then we iterate over the episode we iterate over number of episodes, and in every episode we find the current policy. Using this policy, we select an action, and we then, for all the time steps, we then take these actions, and using that reward we get and the bootstrapping as well, we'll try to code the update for SARSA and update this Q function. Okay, and we'll repeat this process over various episodes. Okay, so I hope this is clear. If you have any doubts till this point, you can like interrupt me and ask. Okay. If there are no doubts, I'll go ahead with the Q learning part. So this function implements Q learning, but it's not fully implemented. The base code is given and you are required to code the Q learning update. This function is very similar to SARSA, and the difference is that here this is the policy that is behavioral policy here is different from the target policy. Okay. Sorry if I missed something, like my connection went down for a while. Yeah, so I was explaining the Q learning function. In this part, we have an additional rollout stats, which are rollout stats for the target policy, which is different from the behavioral policy. Okay, so here we'll track how the target policy is doing over episodes. Okay, so yeah, so for this part also, you are only required to code the update step for Q learning. Now, this is also given in, we saw this in class, and also it is in the book, the update step for the Q learning. Okay. Now, like after implementing these, we'll try to see how these algorithms perform, and we will then plot their rewards over how much reward these policies are getting over episodes. So we'll see, we'll plot them, and this will help us gauge on how the learning is happening. Okay. Another piece of code which is given is, once these policies, once you learn the Q functions, we can extract greedy policies from these Q functions and just visualize like how the policy looks like. So this visualization is a visualization of a greedy policy which is extracted from the Q function, just to see what path the greedy policy will follow. Okay, so for SARSA, the behavioral policy is not greedy, but this will just let us see how the policy would be, because the policy in epsilon greedy, which is close to greedy. So we'll just see for SARSA in this, that what a greedy policy will look like. So for this, we'll do for both SARSA and Q learning. The visualizations are not available in here because this visualizations will be generated after we have coded the update for Q learning and the different update for the SARSA algorithm as well. Okay. After let's go ahead and see the third part, which discusses various SARSA variants. So for the SARSA variants, we'll implement the SARSA algorithm with various values of epsilon. So these values of epsilon affect the policy that is basically the behavioral and the target policies as well, which is same for SARSA. So we'll do this for various values of epsilon. We'll do this for, we have already done it for epsilon 0.1. We'll do it for epsilon 10 to the minus 6 and 5 into 10 to the minus 3. And we'll see how they perform and what policies are generated from them and how the learning happens in that scenario. We'll also implement a variant of SARSA with decreasing epsilon. So here we'll start with some initial, like we'll implement this with an epsilon which is 1 by the step number. So step number is the number of steps that the algorithm will take, and this, for this you can use the base code for SARSA which is given and implement that with an epsilon, decreasing epsilon, which is given by epsilon equal to 1 by step number. Okay. After this, these things will help you compare their compare and see how learning is happening. Okay. After this, we'll visualize the policies that are generated using this. So we'll extract a greedy policy out of the queue function that we have, which is generated by these algorithms, and then that will help us visualize the greedy policies which are there for various. So we will be able to see what paths they will follow after learning has happened. Okay. So after this part, the assignment asks us to explore this interesting thing in which we'll explore that whether learning will happen with a random behavior or not. So for this part, we'll implement queue learning with a random behavior. So here, the policy which the agent will follow while learning will be a uniformly random policy in which the probability for selecting any action will be equal. So you have 4 actions at each step, but the probability of selecting any of these actions is equal. So we'll see that with this random behavior or a random policy in the learning framework, will the queue learning algorithm be able to learn the optimal policy or the optimal target policy. So in the learning loop, we will have a random, uniformly random policy, but while executing, we'll extract a target policy, which is a greedy policy, out of the queue function which is being updated. So here we'll see that if the queue function gets updated or not, and this here this part requires you to code basically queue learning with a random behavioral policy. Okay. After this, there are some questions which you are required to answer based on the insights that are generated from coding this part. For this also, you can use the base code which is given for the queue learning algorithm. Okay. This will help you generate some insights into how this is performing versus the normal queue learning. Okay. Then for the bonus parts, these are not compulsory to submit, but you can very interesting to try. And for these parts, you are required to code. It's optional though. The n-step SARSA algorithm and also the SARSA lambda algorithm. For these parts also, we can compare them to classical SARSA and also see what policies are generated and compare it to the classical SARSA policy. Okay. Now this concludes the discussion. If there are any doubts regarding the assignment 3, feel free to ask.